Hello students, welcome to the next class of complex numbers. Let us look at some more problems on complex numbers. Okay, look at the next question. Question 11. The value of 1 plus I whole power 6 plus 1 minus I whole power 6 is. For this problem I will give you two methods. First method, 1 plus I whole power 6 plus 1 minus I whole power 6. I will write 1 plus I whole power 6 as 1 plus I whole square whole cube plus 1 minus I whole square whole cube. Then 1 plus I whole square, I will expand it by using a plus b whole square formula. A square, that is 1, plus b square is I square, plus 2ab, which is 2i whole cube, plus here again a minus b whole cube I am using. A minus b whole square, a square is 1, plus b square is I square, minus 2ab, that will give you minus 2i whole cube. Okay. I square, what is the value of I square? Minus 1. 1 to minus 1 gets cancelled. So we will have 2i whole cube, plus here I square is minus 1, 1 to minus 1 gets cancelled, minus 2i whole cube. Okay. So I can write this as 2 cube into I cube, that means 8 into I cube, and here it will become minus 8 into I cube. Minus 2 whole cube, that is minus 8 I cube. 8 I cube minus 8 I cube gets cancelled. So the answer is 0. First option. This is one way of solving this problem. There is another method also, that is by using polar form, writing this complex number in polar form and then by using De Moivre's theorem. What does De Moivre's theorem say? It says that cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. In short form, cis theta. Cis theta is the short form of cos theta plus I sin theta whole power n is equal to cis n theta. This you know. Okay. So for that, I have to ensure that both the complex numbers are in polar form. 1 plus I. In polar form, how do we write? If r is the modulus and theta is the amplitude of a complex number, then we write the complex number as r into cos theta plus I sin theta. That is a polar form or modulus amplitude form. R. So for this 1 plus I, what is r? R is given by r. The modulus is given by root of x square plus y square. In this complex number, x is 1 and y is 1. So root of x square plus y square means 1 square plus 1 square, which is 2. So modulus is root 2. Amplitude. Amplitude is here, this complex number is represented by the point 1, 1. So x is 1, y is 1. 1, 1 lies in the first quadrant. When the complex number lies in the first quadrant, then amplitude theta is equal to alpha. What is alpha? Tan inverse of modulus of y by x. So in this case, tan inverse of 1 by 1, which is tan inverse 1, that's equal to pi by 4. So 1 plus I can be written as root 2 into cis pi by 4. Then what about 1 minus I? 1 minus I, it is the conjugate of 1 plus I. When they are conjugates of each other, then their modulus will remain the same and amplitude will be minus of the amplitude of the given complex number. So here pi by 4, so it will be minus pi by 4. Okay. Then what do we want? 1 plus I whole power 6 plus 1 minus I whole power 6. So I can write this as root 2 cis pi by 4 whole power 6 plus root 2 cis of minus pi by 4 whole power 6. That's equal to root 2 whole power 6 can be written as 2 cube. Then cis pi by 4 whole power 6. It looks like a cis theta whole power n. That's equal to cis of n theta. So it will become cis 6 pi by 4 plus in the next term also root 2 whole power 6. That will give you 2 cube. Cis of minus pi by 4 whole power 6. Cis theta whole power n is equal to cis n theta. So cis of minus 6 pi by 4. Okay, 2 cube I will take common. 2 cube is equal to 8. I will take common. Cis 6 pi by 4. 6 pi by 4 can be written as 3 pi by 2. Cis 3 pi by 2 is nothing but cos 3 pi by 2 plus I sin 3 pi by 2. Okay. Then minus 6 pi by 4 minus 3 pi by 2. It is cos of minus 3 pi by 2 plus I sin minus 3 pi by 2. Cos of minus 3 pi by 2 is cos 3 pi by 2 itself. Sin of minus 3 pi by 2 can be written as minus sin 3 pi by 2. So you get minus I sin 3 pi by 2. Okay. So here this I sin 3 pi by 2 gets cancelled. Cos 3 pi by 2 cos 270 degree equal to 0. 0. This is 0 into 8. Then product is equal to 0. This is the other method. You can either use this one or that one. Choice is yours. Okay. Let us look at the next question now. Summation n from 0 to infinity 2I by 3 whole power n. Summation n from 0 to infinity 2I by 3 whole power n. This is equal to. Go on putting values for n starting from 0 to infinity. If I put n is equal to 0, 2I by 3 whole power 0, that is 1. Plus put n is equal to 1, 2I by 3. Put n is equal to 2, 2I by 3 whole square. Put n is equal to 3, 2I by 3 whole cube, and so on. Okay. Observe that this is a series expansion. It is in GP. This is a geometric progression with the first term 1 and common ratio 2I by 3. So there are infinitely many terms up to n from 0 to infinity. Infinitely many terms here. This is there are sum to infinity of a GP. That formula we know. S infinity of a GP is given by A by 1 minus R, where A is the first term and R is the common ratio. So this is equal to A by 1 minus R, A is 1, divided by 1 minus R, R is 2I by 3. Okay. Let us simplify this because this option is not available there. Let me take LCM, 3 is the LCM, then that 3 will come up to the numerator. It will become 3 divided by 3 minus 2y. Further we will simplify it. We want it in the form A plus IB. As you can see, all the options are in the form A plus IB. So for that I will multiply and divide by the conjugate of the denominator. Okay, that's equal to, it will be numerator by 9 plus 6i. Denominator A plus B, A minus B, A plus B, that is A square minus B square. 9 minus 4i square. I square is minus 1. Minus 4 and minus 1 will come plus 4. 9 plus 4 is 13. So answer is 9 plus 6i divided by 13. 9 plus 6i by 13. First option. Let's go to the next question now. The multiplicative inverse of 3 plus 4i divided by 25i. 3 plus 4i by 25i. We want the multiplicative inverse. I gave you one formula. Multiplicative inverse of a plus ib is a minus ib divided by a square plus b square. Okay? In other words, this is nothing but the reciprocal of this. You can see reciprocal of a plus ib is 1 by a plus ib. We say this is the multiplicative inverse of this complex number because when I multiply these two, the product will be equal to 1. So if I multiply these two, then also product will be 1, right? This only after simplification we get this. If I multiply and divide by the conjugate of the denominator, that will give you a minus ib by a square plus b square. Okay? I advise you to use this formula if the given complex number is in this form. Okay? If the given complex number is not in this form, as it is the case now, it's not in the form a plus ib, then better you take reciprocal and simplify it. Okay? So, this is the complex number we have. We want its inverse, its multiplicative inverse. That is the reciprocal of this. What is the reciprocal of this? 25i divided by 3 plus 4i. Reciprocal of this. Okay? So, now you simplify it. You bring it to the form a plus ib. For that I will multiply and divide by 3 minus 4i. 3 minus 4i. Okay. So numerator will be 25 into 3, that is 75i. 25 minus 4i, so that is minus 100i square. Denominator 3 plus 4i into 3 minus 4i. 9 minus 4I square. Sorry, 4 square I square, that is 16I square. I square is minus 1. Minus 100 into minus 1, that will be plus 100. So I will write that as 100 plus 75I divided by I square is minus 1. Minus 16 into minus 1 is plus 16. 9 plus 16 is equal to 25. Then we can split it 100 by 25. That's or you take 25 as common factor. Then what is left? 4 plus 3I. 4 plus 3I. 4,000. Sorry, 3,000. 4 plus 3I. Okay. Let's answer the next question now. The conjugate complex number of 2 minus I divided by 1 minus 2I plus 2I. The conjugate complex number of this. Okay. So what they are asking is, we are asked to find the conjugate of this number. So to find the conjugate of this number, this complex number, what we do is, first we will bring it to the standard form. That is, we will bring it to the form a plus I. Not just for this question. For most of the questions, like you may be asked to find the real part of this complex number, find the imaginary part, or like find the conjugate, or find the multiplicative inverse. It is always better to bring it to the standard form. Okay, bring it to the standard form first. So for that, 2 minus I divided by, here I will expand it. 1 square, that is 1 plus 4I square minus 2AB, that will be minus 4I. That's equal to 2 minus I divided by I square is minus 1. So it will become minus 4. 1 minus 4 is minus 3 minus 4I. 1 minus 4 is minus 3. Minus 3 minus 4I. Okay. 2 minus I divided by minus 3 minus 4I. Now let us further simplify it. We have to multiply and divide by the conjugate of the denominator. That is minus 3 plus 4I. Minus 3 plus 4I. Okay. So then numerator will be minus 6 plus 8I plus 3I minus 4I square divided by minus 3 into minus 3. 9 minus 3 whole square minus 4I whole square, that will become minus 16I square. A minus b into a plus b, a square minus b square. A square is minus 3 whole square, which is 9. Minus b square minus 4I whole square, that is 16I square. I square is minus 1 here. Minus 4 into minus 1 is plus 4. Minus 6 plus 4 will give you minus 2. 8I plus 3I is 11. 16 into I square is minus 1. Minus 16 into minus 1 is plus 16. 9 plus 16 is 25. That's the answer. Minus 2 plus 11I divided by 25. Or I can split it as minus 2 by 25 plus 11 by 25 into I. Minus 2 by 25 plus 11 by 25 into I. Third option. Okay. Let us look at the next question. The complex numbers sin x plus I cos 2x and cos x minus I sin 2x are conjugate to each other for x over n pi, for x over n plus 1 by 2 into pi, for x over 0, for no value of x. Okay. So they have given two complex numbers. One of them is sin x plus I cos 2x, and the other one is cos x minus I sin 2x. Okay. So what they have given is that these two complex numbers, they are conjugates of each other. The conjugate of this first complex number is equal to the second, and the conjugate of the second complex number is equal to the first. So I will take the conjugate of this. Conjugate of a plus I is a minus I. So the conjugate of a minus I is a plus I. Cos x plus I sin x. This is the conjugate of this one. Given that these two are conjugates of each other, means this complex number must be equal to this. So I can write sin x plus I cos 2x is equal to cos x plus I sin 2x. Okay. Two complex numbers are equal. Two complex numbers are equal is possible only if real part of this complex number is equal to real part of that complex number, and the imaginary part of this is equal to imaginary part of that. So if I equal the real and imaginary parts, sin x must be equal to cos x. Okay. And then cos 2x must be equal to sin 2x. sin x is equal to cos x. So then it will happen when x equal to pi by 4. But will it happen? Will it hold good at x equal to pi by 4? If I take x is equal to pi by 4, I am talking about cos pi by 2 is equal to sin pi by 2. Is it true? Cos pi by 2 is 0, sin pi by 2 is 1. They are not. So I cannot find any value for x which will satisfy this equation also, which will satisfy this equation also. There is no such value of x that satisfies both the equation. Hence, there is no value of x. Okay? There is no value of x which will satisfy both the equations. Hence, the answer is no value of x. If I look at this, pi by 4 is the answer. If I look at it, pi by 8 is the answer. Pi by 8 is one solution for this. You can cross check. If I put x as pi by 8, 2 into pi by 8 will give you pi by 4. Cos pi by 4 is equal to sin pi by 4. That is true. But you cannot say for this x I will put pi by 4 and for this x I will put pi by 8. That is not allowed. So there is no value of x for which these two, both the equations will hold good. Hence, answer is no value of x, fourth option. Okay, so now another question. If 2 minus I by 1 minus 2i whole square, 2 minus I divided by 1 minus 2i whole square, and minus of x plus 11i divided by 25, they are the conjugate complex numbers, then what is the value of x? So conjugate of this complex number is equal to this, then what is the value of x? Okay. I want the conjugate of this. I think already we have solved the same problem earlier. Okay. Anyway, let me solve again. 1 minus 2i whole square, if I simplify it, I am going to get 1 plus 4i square minus 4i. That is equal to 2 minus I. I square is minus 1. 1 minus 4 is minus 3. Minus 4i. Multiply and divide by minus 3 plus 4i. Okay? That is equal to minus 6 plus 8i plus 3i minus 4i square divided by 9 minus 16i square. A minus 8 into a plus b. I square is minus 1, so it will become plus 4 here. Minus 6 plus 4 is minus 2 plus 11i. Here I square is minus 1, minus 16 to minus 2 will give you plus 16, 9 plus 16 is 25. This is the given complex number, minus 2 plus 11i by 25. We want the conjugate of this complex number. Conjugate is minus 2 minus 11i divided by 25. That's the answer. Given that it is equal to minus of x plus 11i divided by 25. I'll take minus as a common factor here. From this, I can write this as minus of 2 plus 11i by 25 is equal to minus of x plus 11i by 25. Now compare them, you will see that x is equal to 2. First option is the right answer. Okay, look at the next question, 24. If alpha and beta are real, then modulus of alpha plus I beta divided by beta minus I alpha is equal to. Okay. So we are asked to find out the modulus of alpha plus I beta divided by beta minus I alpha. Okay. There is one of the properties of modulus, which modulus of z1 by z2 is equal to modulus of z1 divided by modulus of z2. So these are two different complex numbers. Alpha plus I beta is one complex number, beta minus I alpha is another complex number. I want to find the conjugate of the quotient of each. I can find them separately. So modulus of z1 by z2 can be written as mod z1 divided by mod z2. So I can write this as modulus of alpha plus I beta divided by modulus of beta minus I alpha. That's equal to modulus of x plus iy is equal to root of x square plus y square. So this will be root of alpha square plus beta square divided by here x minus iy, root of its modulus is root of beta square plus minus alpha whole square. That is nothing but alpha square. Root of alpha square plus beta square gets cancelled. So the answer is 1. Second option. Okay. Look at this question. If root 3 plus I whole power 100 is equal to 2 power 99 into a plus ib, root 3 plus I whole power 100 is equal to 2 power 99 into a plus ib, then what is a square plus b square? That's the question we asked. So root 3 plus I whole power 100, if I try to expand it, root 3 plus I whole power 100, you can use binomial theorem and expand it, which will contain 101 terms, and I don't have that much space here, neither the time nor the space. So let us find some other alternative for that. Okay. Root 3 plus I, write it in polar form. Polar form means r into cis theta or r into cos theta plus I sin theta. What is r? R is the modulus, root of x square plus y square, and theta is the amplitude. Okay. R, root of x square plus y square. So what is x here? Root 3, and y 1. So I want r root of x square plus y square. That's equal to root of root 3 whole square, which is 3. 1 square, that is 1. Root of 3 plus 1, root 4, that's equal to 2. So modulus is 2. Okay. Then I want amplitude, root r into cis of theta. Root 3 plus I is represented by the complex number by the point root 3 comma 1. Root 3 comma 1 lies in which quadrant? It lies in the first quadrant. When the complex number lies in the first quadrant, then theta is equal to alpha. Alpha is nothing but tan inverse of modulus of y by x. So in this case, alpha is equal to tan inverse of y by x, 1 by root 3. Modulus of 1 by root 3 is 1 by root 3 only. Tan inverse 1 by root 3 is equal to pi by 6. Correct. So this is equal to 2 into cis pi by 3. Root 3 plus I can be matched to cis pi by 3. So then what about root 3 plus I whole power 100? That's equal to 2 power, or here I write 2 into cis pi by 3 whole power 100. That's equal to 2 power 100. So this is like cis theta whole power n. Cis theta whole power n is equal to cis n theta. So this will give you cis 100 pi by 3. Cis 100 pi by 3. Okay. Sorry, pi by 6. Sorry, make that correction. Pi by 6. Cis 100 pi by 6. 100 pi by 6 can be written as 50 pi by 3. Right? Now expand it. 2 power 100 into cis 50 pi by 3 is cos 50 pi by 3 plus I sin 50 pi by 3. Okay. As we know, cos theta and sin theta, they are periodic functions with period 2 pi. So from any angle, if I subtract 2 pi or any multiple of 2 pi, then there is no change in the value of the trigonometric function, which you know, right? So from 50 pi by 3, I will subtract any multiple of 2 pi. Let me subtract 16 pi from this. Say, I will go for this 50 pi by 3 minus 16 pi. That will give you 2 pi by 3, right? Take LCM, 3 is LCM. 3 into 16 pi, 48 pi. 50 pi minus 48 pi will be 2 pi by 3. Okay? So, this is equal to 2 to the power 100 into cos 2 pi by 3 plus I sin 2 pi by 3. Now you might be thinking, sir, how do we get to know that we should subtract 16 pi only? Why not 2 pi, 4 pi? Yes, you can. You can subtract 2 pi, 4 pi, 6 pi, 8 pi, etc. You can subtract them as many times as you wish. My intention is I want to bring that angle between 0 and 2 pi, that is between 0 and 360 degree, because those are the well-known angles. If it is 735 degrees, 745, 1110, etc., that is difficult to simplify. But I want it to be in between 0 and 2 pi, that is in between 0 and 360 degree. For that, whatever that is necessary, I am subtracting it. Okay? So, now these are well-known values. 2 power 100 cos 2 pi by 3, cos of 120 degree, which is minus 1 by 2. Sin 2 pi by 3, sin 120 degree, root 3 by 2. Okay. This is on LHS mode. But on RHS what I will do? Okay, so I will write in place of root 3 plus I 1 power 100, I will write this 2 power 100 into minus 1 by 2 plus I root 3 by 2. Then on RHS I will substitute this 2 power 99 into A plus IB. Okay, here we have 2 power 100 and here we have 2 power 99. 2 power 99 gets cancelled. Another 2 will remain. That 2 I will take it inside. So when I take that 2 inside, here 2 gets cancelled. Minus 1 will remain. Here also 2 gets cancelled. I root 3 will remain. That is equal to A plus IB. Because this I have cancelled that 2 power 99. Okay, so minus 1 plus I root 3 is equal to A plus IB. What do you want? You want A square plus B square. A square plus B square. A square is minus 1 whole square, that is 1. Plus B square is root 3 whole square, which is 3. So the answer is 4. 1 plus 3 is equal to 4. Second option is the right answer. Okay, I will solve one more problem in this class. If x plus iy is equal to square root of a minus ib by c minus i, then x square plus y square whole square. Okay. See what they have given? They have given that x plus iy is equal to root of a minus ib divided by c minus it. Then what is x square plus y square whole square they are asking. Okay, x plus iy is equal to this. From this, can you tell me what is x plus iy? X minus. What I am doing here is, in this equation, I am replacing I with minus I. Wherever there is I am replacing it by minus I. Replacing I by minus I. Okay? When I replace I by minus I am going to get x minus I by is equal to. So this a minus I will now become a plus I. C minus I will be C plus I. Will become C plus I. Okay? Now I multiply these two equations. Let me name them as equations 1 and 2. I am multiplying these two equations. On the left side, x plus iy into x minus iy. And on RHS, we have a minus ib by c minus ib into a plus ib divided by c plus ib. Okay? A plus ib by c plus ib. So here x plus iy into x minus ib, a plus b into a minus b. This will give you x square minus I square y square. That's equal to square root of a minus ib into a plus ib. That I write as a square plus b square. Similarly, in the denominator, c square plus b square. Actually, I am getting my a square minus I square b square. As we know, I square is minus 1, so minus of minus b square will become plus b square. And here I square is minus 1, so this will be x square plus y square. I'll write here x square plus y square is equal to square root of a square plus b square divided by c square plus d square. Okay? Now square this out, because we are asked to find out x square plus y square whole square. Squaring this equation will give you x square plus y square whole square is equal to a square plus b square divided by c square plus d square. A square plus b square by c square plus d square, which is option C. Okay, students, with this I will stop today's class. We will continue tomorrow. Thank you.